Chapter 11. Force and pressure. Force, a push or pull. This is a box. To move it from its place, you can either push the box or pull the box. This push or pull is called force. The direction in which the body is pushed or pulled is called the direction of force. To open a closed door, you can pull the door, and the door moves towards you. To close an opened door, you can push the door, and the door moves away from you. When a load is suspended from a spring, the spring stretches in the direction of load. For squeezing out the color from the tube, you can squeeze the tube and the tube gets deformed. Force is applied by interaction. An interaction of one object with the other object results in a force between the two objects. If you are standing behind a stationary car, it will not move by itself as there is no interaction. To move the car, you have to interact with the car by applying a force on it. What can force do? A force can make a stationary object to move. If you push a stationary trolley, it can move in forward direction. A force can change the rest position of an object. For drinking water, you can pick up a glass of water from the table. A force can change the speed of a moving object. You can give a push to move it faster. A force can stop a moving object. A goalkeeper stops a football by applying the force in the opposite direction to which the football is moving. A force can change the direction of a moving object. A batsman changes the direction of the moving ball by hitting it with its bat. A force can change the shape or size of an object. If you pull a spring from its both ends, it increases its size. Pressure. Take a pencil, sharpen it at one end. Hold the sharpened pencil between the index fingers of both your hands and press it from both sides. On which finger do you feel pain? On which finger does the pencil leave a deeper mark? You may feel the pain in the finger which is at the pointed end of pencil, and the pencil leaves the deeper mark on the same finger. It is the effect of force in the terms of area on which it acts. This aspect of force is described by a quantity called pressure. Pressure is defined as the force exerted per unit area. Pressure is equal to force per unit area. Unit of pressure. The SI unit of force is Newton, N, and the area is measured in meter square, m square. So, the unit of pressure is Newton per square meter, or N/m square. It is commonly known as Pascal, PA, after the name of French scientist Blaise Pascal. Example of pressure. A camel can easily walk on sandy ground. This is because the pressure exerted by the broad feet on the sand is quite small, due to which the feet do not sink much in the sand, and the camel can easily walk on it. Drawing pins can easily be pressed into the soft wood board. This is because the drawing pins have relatively much larger top and are highly pointed at lower end. That is why these can be easily pressed into the soft wood boards. Pressure exerted by liquids. Drill 3 small equal holes in the side of a tall can at different heights from its bottom. Now fill the can with water. You will see that water rushing out from the lowest hole is going farther. From the highest is falling near the can, and that from the middle hole is falling in between the two holes. It will prove that the pressure in a liquid increases with depth. Drill a few equal-sized holes all around a can at the same level. Fill the can with water. What do you observe? you will observe that the water rushing out of each hole is falling at the same distance from the wall of the can. This shows that the pressure of a liquid is the same in all directions at the same depth.